A very good day to our lecturer and my fellow friends. Today, for Lab 9, I will be explaining about the introduction of this lab where majorly we'll be using two terms in physics, which is the free fall and the moment of inertia. So, free fall is a major example of uniformly accelerated movement. A free-falling body undergoes uniformly accelerated motion in close proximity to the Earth when the air resistance is negligible in relation to the weight of the body, as first discovered by Galileo. All bodies, regardless of their shape, nature, and weight, fall equally quick as a result. This motion is termed as free fall. The amount of acceleration of free fall is gravity equal to 9.81 meter per second square. And a free-falling body's final speed is determined only by the height which it has fallen. And below is the formula for the one we're going to use for the lab. And next will be the moment of inertia. Moment of inertia is defined as stating that any mass point remains at a rest or in a state of uniform movement on a straight path as long as no forces are acting on it according to Newton. So, depending on the distance of the mass from the rotational axis, a body may have a different moment of inertia. And the moment of inertia for our experiment is J equals to 102 m dot r square. Thank you.
Hi everyone, my name is Dinesh and my metric study is MH1070. Now I am going to talk about the experiment on rolling disc on inclined plane. The objective of the experiment is to understand the mass moment of inertia by rolling experiment. Next is to understand the mass moment of inertia by pendulum experiment. And finally, the law of falling bodies on an inclined plane. And I also will talk about the apparatus that we use on this experiment. First is plank wood. We use a 1 meter plank wood. Next, golf ball. Then we use cake jar. And last apparatus that we use is stopwatch. Thank you.
Assalamualaikum and hi, my name is Adila MA19049. So I will present about the theoretical background of the rolling disc on inclined plane. So the motion of a wheel which is rolling around along the ground or the plane without slipping can be considered in one of two ways. First is rotation of the wheel about an axis through its centers of gravity. Next is an additional translation motion of the entire wheel with the same velocity as the center of gravity. Then I will discuss about the formula used in this lab. We mainly use three formula. First one is the acceleration equation, where acceleration is equal to the mass is equal to the product of the mass and acceleration due to gravity multiplied with the sine of inclined angle and square of roll radius divided by mass moment of inertia. The second formula is mass moment of inertia equation, which is J equal to half times mass times the square of disk radius. The last is the time, which is T is equal to square root of 2 times distance divided by accelerations. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iskandar Ashraf, metric ID MH18034, and this video will be discussing about the results, how the experiment was proceeded, and I will show you a demonstration how did I conduct the experiment. With the help of a protector, I was able to conduct the experiment successfully. So as I rolled it, when it hits the wall, I will stop the timer and record the time, and thus do a certain calculation to check the acceleration, the calculated time, and calculate standard deviation. So that is all from me. Thank you very much.
Assalamualaikum and very good evening to my lecturer. My name is Muhammad Arif bin Azani, MA.53, and today I would like to walk you through to the discussion on the last experiment, which is laboratory 9. So let's get started. For question number 1 is how to adjust the inclination. Since the experiment was conducted without a proper equipment, we only use a stacking of blocks to adjust the inclination of the plane. For the next one is the what is the purpose of the angulometer. Angulometer is used to measure the exterior angle of the inclined plane. So in this case, we will measure the inclination on the plane that touches the ground. Onwards to the next question is, can you give an alternative method to measure the angle inclination? So without the proper equipment, since the experiment is conducted at home, we are currently using protector to measure the exterior angle. So to make a proper alignment for this experiment, we need to have a flat surface and a plank of wood that doesn't have a bumpy surface. Due to improper equipment, we won't be able to conduct the angle inclination more than 7 degrees, since it will result in error due to the limitation of the equipment. According to Galileo, he says that all object falls with the same acceleration despite of its weight and its size. There are two factors that are actually causes a free falling body. So if the first one, since we are on Earth, of course there's a gravitational force, thus we have the gravitational acceleration. The second one is the height to cause the object to free fall. Since the relationship of gravitational potential energy is directly proportional to its height, so the greater the height, the greater kinetic energy will produce when the rolling disc rolls down the plane. So the term inertia can actually be related to the Newton's first law of motion. So if a body is moving at a constant speed, it will keep moving at a constant speed unless an unknown force acting upon it. For instance, when the footballer changes the direction of the ball is kicking.
So we will continue with discussion number 10. My name is Farid bin Muhammad Nurisham, MH19059. Discussion number 10. Why repeatability of the measurement is important? The repeatability of the measurement is important to obtain an average value. First trial could result in error. For example, a slight push on the rolling disc might cause it to have an extra force acting upon it. Thus, it will roll down faster. Discussion number 11, free body diagram. So this is the free body diagram of the inclined plane. Discussion number 12, why deviation occur between calculated and measured value? To measure result accuracy, measured value might have an error caused by human itself. Thus, the deviation helps to identify the percentage of difference between calculated and measured value. Discussion number 13, suggest improvement of the experiment. I would like to suggest to use an angulormeter instead of protractor to obtain far more accurate exterior angle. Rolling object used must be a solid object without air occupying in it. Conclusion. Based on the data obtained, the higher the angle inclination, the greater the acceleration. This shows that the relationship between the gravitational potential energy is directly proportional to height. As an object falls from a higher ground, it tends to have a greater potential energy before it is converted into kinetic energy. That's all from us. Thank you.